Okay, so in this video we're going to find the derivative of this function here, arctangent of y over x. And the function here is a function of two variables, f of x and y. So we can't just take the normal derivative of that, we have to take what's called the partial derivative. I'm going to write that down like this. So partial derivative of f, that's the name of the function. And you take it with respect to either of the variables. So here we do x, and then we'll also have a go at the partial derivative with respect to y while we're doing it. So arctangent of y over x. Now there's a general formula for the inverse tangent, as we know from our single variable calculus, is arctan of u of x, and then take the derivative of that. That equals 1 over u of x squared, and then add 1. So that we know from single variable calculus. And then we take the derivative of what's inside and multiply it. So times u prime of x. So that's our general formula. Now we're going to apply this into the partial derivative. So with respect to x, we'll use the 1 over u of x squared. Well, in this case, it's the y over x. So let's just, u of x for our formula here is y over x. Okay, so 1 over y over x squared. So it's all squared, and then plus the 1. And then we're going to multiply it by the derivative of u of x, but with respect to x. So how are we going to find the derivative of this with respect to x? Well, first thing we do, we treat y as a constant. So with all constants we can bring them out the front and then take derivative of what's left. So u prime of x equals y times the derivative of 1 over x, that's what's left. And the derivative of 1 over x we know is minus 1 over x squared. So that's that. So then that equals minus y over x squared. So now we put this into the top of here, minus y over x squared. Okay, so now we're left with minus y, then the x squared come down to the bottom, and then we'll distribute y over x squared is just y squared over x squared, and then plus 1. Okay, now distribute the x squared into all these. Then that equals minus y. Y squared times x squared over x squared just leaves y squared. And x squared plus times plus 1 is just plus x squared. And then that is our partial with respect to x. Okay, now let's move on to this one, partial with respect to y. So using our general formula, we've got 1 over y over x squared plus 1. This time we need the partial with respect to y. So now we'll call this function u of y. So let's write that down now. So u of y equals y over x. So then we get 1 over x. Take that out because that's our y over x. What am I writing that for? Y over x. So we take the 1 over x out because we're only taking derivative with respect to y, and then multiply by the derivative of y, which is 1. So that just leaves us with 1 over x. That's times 1 over x. Okay, so as we did before, let's bring this x down and then distribute. So we've got 1 over x times, again as before, y squared over x squared plus 1. Okay, now we need to try and get rid of this x squared if we can. So if we multiply top and bottom by x over x, which is the equivalent of multiplying by 1. So let's multiply this by x over x. So that will leave us with an x on the top. Keep this separate. And then x here becomes x squared. Let's just write that in. Let's go one step at a time here. So x squared times y squared over x squared plus 1. Okay, now as before, we can do some cancelling out. Distribute this into here, they cancel, and then this one just becomes x squared. So now we're left with x over y squared plus x squared. Okay, that's our partial with respect to y, and that's our partial with respect to x.